right, here we are in section 11.2, a first application, marginal analysis. This is early on in math for the social sciences 1, also the math 1320 that you took earlier. Whether you came in with the credit or you took it here at UTEP. We do marginal analysis early on when it comes to our business students. I just noticed that. So here we go. A cost function specifies the total cost C as a function of the number of items X. In other words, C of X is the total cost of X items. The marginal cost function is the derivative, C prime of X, of the cost function C of X. Keep in mind, previously, a linear cost function. It's funny, I just taught this lesson last week in Math 1320. The linear cost function, M, the slope, is the marginal cost. Well, guess what? M, slope, M, marginal cost, it's also the derivative. All right, so the marginal cost, the slope of a linear cost function, this is the derivative, but cost functions do not always have to be linear. Now that we have calculus, we don't have to just look at linear, just looking at marginal cost. Now we're going to kind of expand on that idea that we saw earlier in an earlier class. This derivative measures the rate of change of cost with respect to X. The units of marginal cost are the units of cost per item. We interpret C prime of X as the approximate cost of one more item. Similarly, we have marginal revenue and profit. A revenue or profit function specifies the total revenue R or profit P, because mathematicians are super creative there, as a function of the number of items X. The derivatives R prime of P, or R prime of X and P prime of X of these functions are called the marginal revenue and marginal profit functions respectively. The rate of change. It's always a rate of change of revenue and profit with respect to X. The units of marginal revenue and profit are the same as those of marginal cost. The amount, the cost, whether it's in euros, pesos, dollars, lira, whatever they happen to be, per item X. We interpret R prime of X and P prime of X as the approximate revenue and profit from the sale of one more item. Let's look at 3 examples. Okay, so the cost of producing X teddy bears per day at the Cuddly Companion Company is calculated by their marketing staff to be given by the formula C of X equals 100 plus 40X minus 0.001X squared. I want to find the marginal cost function. I'm going to find C prime of X and use it, so I stop reading. I'm not even reading the rest. The first phrase says, find the marginal cost function. Here's my cost function. That says, find the derivative. I can do this. The derivative of 100, that's a constant. The derivative is 0. The derivative of 40x. If I had a line, y equals 40x, what would its slope be? Its slope is the coefficient of x to the power of 1, so that's 40. Minus sign. I'm going to leave the coefficient, 0.001. I'll take the derivative of x squared. Also, I'll bring down the 2, leave the x. 2 minus 1 leaves a 1 as my new exponent. When I put this together, right, I just use the rules. When I simplify, my marginal cost function is 40 minus 0.002x. Awesome. Now I abandon the problem in the middle of reading it, so I go back. Find the marginal cost function, done. Use it to estimate how fast, right, because it's a rate of change. We'll use the changing one, the derivative. How fast the cost is going up at a production of 100 teddy bears. All right, so cost of production, I could estimate. At 100 bears, I'm using the marginal cost function, so I put 100 in for X. All right, 100 in for X, I'll have 40 minus 0.2, $39.80 per bear, right? Cost, the marginal cost is cost per item. So the cost is going up at 100 teddy bears at production level. The changing cost is $39.80 per bear. All right. Now, let's compare this with the exact cost of producing the 101st teddy bear. Now, If I were to build 101 teddy bears, my cost would be $4,129.80. If I were to build 100 teddy bears, one less, right? The cost of 100 teddy bears subtracted from the cost of 101 teddy bears is the cost of the 101st teddy bear. I substitute my values and I get $4,090. And when I do the subtraction, I find that the marginal cost, the cost to make the next bear, is $39.80, which is exactly the same as if we were just to use old school algebra. We can get there much quicker using this method. What's the marginal cost for 200 bears at a production level of 200 teddy bears? I could find that. If I use this method, I would have to find C of 201 minus C of 100 and go from there. All right? But marginal cost, slope, derivative allows us to find production levels. Okay, now the average cost function, this is important. This is something you will absolutely need to know. Average cost is notation C bar of X, and it's always cost divided by X. Always. It's the cost function divided by X is the average cost function. And then we're going to evaluate it. So C bar of X, the first thing I do to create it is I'll take the function 100 plus 40x plus 0.001x squared, and I'll write it over top of x. Literally just wrote the cost function, drew a fraction bar, put the x in the denominator. But now I'm going to go to each one. That's 100 over, all over a common denominator. I can separate these. 100 over x plus, all right, plus sign. 40x divided by x leaves me a 40, minus sign. 0.001 x squared divided by x leaves me with a single x. All right, so I separated. Instead of a common denominator, I used x in 3 different denominators and simplified individually. Now, after I found the average cost function, I'm going to evaluate C bar of 100. So I put a 100 in. Everywhere I see an x, that's 100 over 100, plus 40 minus 0.001 times 100, and I'll get 4090. What is that? Average cost function. It's the cost per item, right? The cost is in dollars, and this is in teddy bears. We'll call him Ted. So that 40.90, our answer right here, means that making the first 100 bears, it cost the company $40.90 per bear on average. To make 50, the first 50 probably cost more, right? The closer you get to 100, each bear costs less. Going forward, the bears are going to cost even less because you've overcome the overhead of what it is just to create something. You have automatic costs. All right, second example. The Audubon Society at ESU, Enormous State University, is planning its annual fundraising eat-a-thon. The society will charge students $1.10 per serving of pasta. The society estimates that the total cost of producing X servings of pasta at the event will be given by C of X equals this function, 350 plus 0.10x plus 0.002x squared dollars. Calculate the marginal revenue and profit functions. Now, we have a cost. Cost is given to us. Revenue, the money we make. That's right here, right? Revenue is what they charge. It's what they make from other people. They charge students $1.10 per serving of pasta. X is the number of servings of pasta. $1.10 times X is our revenue function. And from there, our marginal revenue is the derivative, which is just $1.10, right? How much am I going to make on this next plate? How much am I going to take in? $1.10, because that's what the next person is going to pay. But remember, profit is revenue minus cost. So I'm going to take my R of X, 1.10x, and subtract my cost function. So 1.10x minus the function given to us. Notice I put it in parentheses here because I will want to distribute to get a negative 350. Here I have a negative 10 cents X. Here I have $1.10 minus 10 cents. So I have 1x. And I have this minus 0.002x squared. 0.002x squared has a negative sign. I threw it in front just so I have a decreasing function written in decreasing orders. Marginal profit, now I could take the derivative, that negative 0.002x squared. So I'm going to multiply by 2. I'll get negative 0.004x. 2 minus 1, so my exponent is 1. The derivative of 1x is 1. And the derivative of any constant is 0, so I didn't bother writing it. I have my marginal revenue, I have my marginal profit, I have my profit and my revenue. All right. So calculate the revenue and profit, and also the marginal revenue and profit if you have produced and sold 200 servings of pasta. Interpret the results. So let's do the math first. The revenue of 200. Revenue at 200, that's $1.10 times 200. We made $220. It didn't matter, right? The marginal revenue, whether you're at 100, 200, or 7, it's going to be $1.10 for the next plate, right? That's how much they're paying. Our profit, however, when we sell 200 plates of pasta and we use our profit function, we end up with a negative $230 profit. Negative and profit, they don't go together well. But the marginal profit, right, when I put in 200, the marginal profit is now 20 cents. So I should gain 20 cents on my next sale, right? After selling 200 servings of pasta, the club has a revenue of $220 with revenue per plate at a constant $1.10 per serving. All right, that's all that means. Take the words, take the numbers, put them together. However, over here in green, the 200 servings has the club still losing $230, bad fundraising. The good news is that the profit per serving is positive, and if it's positive, that means it's increasing. And so after these first 200, now you're going to start picking up, you're going to start making some good money, and you might actually raise money instead of just give away good pasta. For which value of x, all right, so I know that in the end, my answer is x equals. For which value of x is marginal profit 0? Interpret your answer. Okay. I want an answer that is x equals. For what value of x? Okay, where am I going to get it from? My equation is marginal profit, p prime of x, equal to 0. Okay, well that's when my p prime of x, negative 0.004x plus 1 equals 0. I added my 0.004x. I divided by 0.004, and I get x equals 250. What does this mean? Interpretation matters, right? It's great that you could do math, but you need to be able to answer questions for people because nobody's ever just going to say, hey, when is p prime of x equals 0? They only want to know what that means. So at 250 servings, the profit per serving is 0. All right, so at 250, we're no longer making a profit. That's a bummer. That's a bummer. Profit per serving, yep. Okay, last example. The cost C of building a house is related to the number K of carpenters used and the number X of electricians used by the formula C equals 15,000 plus 50K squared plus 60X squared. This is a function of two variables, so two things change at a time. Assuming that 10 carpenters are currently being used, find the cost function C. All right, so I'm going to put 10 in for carpenters. My K value is 10. I'll put it in here, all right? 15,000 plus 50 times 10 squared, that's a 10, not a 20, plus 60x squared. 10 squared is 100. 100 times 50 is 5,000. I'll have 15,000 plus 5,000 to give me 20,000 plus the 60x squared. All right, so if we have 10 carpenters, now we have a cost function based on the number of electricians used. All right. Assuming 10 carpenters are being used, find the cost function. Got that. The marginal cost, C bar, so now I need to take the derivative of 20,000, that has no variables, that is a constant, that derivative is 0. 60x squared, I will leave the 60. I will bring down the 2 from the exponent, subtract 1. 2x to the 2 minus 1. 2 minus 1 leaves us with a 1. 60 times 2 is where we get our 120x. All right. So we got cost, we got marginal cost, and average cost. All right. Average cost is we take cost function, exactly what the cost function was. We divide it by x. I'm going to take them individually. 20,000 divided by x plus 60x squared divided by x. The x squared over x simplifies. So now we're going to use these three functions. All right, we have the three different ways of analyzing cost here. The total cost of x items, the cost for making the next item, and the average cost for making x items. All right, so we're going to use the functions we obtained, compute c prime of 15 and c bar of 15. Let's start with that sentence. C prime of 15, 120 times x, it's 120 times 15, 1,800. But what is this cost? The cost is in dollars. What's my input? My input is 15. X is the number of electricians. $1,800 per electrician when we have 10 carpenters and 15 electricians. What's the average cost at 15 electricians? That's 20,000 divided by 15 plus 60 times 15. So the average cost is $2,233.33 per electrician. When you have 15, all right, per electrician, we're getting that. Average cost is decreasing. Oh, wait. Use these two answers. I forgot. We had to read the instructions. Use these two answers to say whether the average cost is increasing or decreasing as the number of electricians increase. Now, the marginal cost, it's $1,800 for the next electrician, right? $1,800 to get the next one. So far, these people are averaging $2,200 per electrician. The next one's going to be $1,800. Notice that's less. The average cost, C bar, is decreasing. Right? It's going down because the cost per electrician is less. Cost per electrician at 15 is less than the average cost per electrician at 15. Okay, the next one is 1,800. The next one is cheaper, so the average cost is going down. Woo! When 18 minutes of math is considered a short one, I feel sorry for my students. Thanks for listening. We'll do 11.3 next.